In this lesson, we are going to focus our attention on understanding how to represent images in Matlab. And so to recap, when we're working with images, we're going to use an unsigned int 8. And so the U means that it's unsigned, only 0 or a positive number. And it's going to be an integer, meaning no decimals. And with it being an 8-bit integer, that means that we're going to start with a minimum value of 0 and have a maximum value of 255. So that is going to go represented in bits as all zeros, so 8 zeros, or the maximum of 255 is all ones. And so we make use of this for showing images and not specific calculations or matrices. So we can cast our numbers as doubles for the calculations, and that can be done to avoid the capping off of appropriate values. And we can also cast them back to an unsigned int 8 value as well. And so we'll be using the image and image show functions as a part of Matlab. So one thing that you want to be aware of before transforming it to an unsigned int is that capping does occur. And capping means that basically for a typical integer value, when you add, so let's say we take the value of 255 plus 5, that's going to get us a value of 260. But if we use the unsigned integer to cast it, then 255 plus 5 is not going to equal 260. It's going to stay at 255, which is the maximum allowable value that we can have. And so the same thing occurs with subtraction. We aren't able to have a negative value. And so if you do unsigned int 5 minus 10, it's not going to give you a negative 5. It's going to just give you a 0. And again, of course, the order of operations do matter as well. So in this case, if we have an unsigned int plus 30 minus 10, that is going to give us a value of 245. And so if we have another value, 245 minus 10 plus 30, then that gives us the value of 255, with the difference being in how we've added and subtracted the order from subtracting unsigned int 10 and subtracting unsigned int 30. And so let's start by discussing or demonstrating how we would create a pixel image. Now you'll want to recall, in order to create an image, we are going to essentially have to declare each RGB value for that image, for the image. And so in this case, if we want to create a red pixel image, we're going to use the img command. And the first two values represent the coordinates of the pixel. So this is row 1, column 1. And then the value for the red component is going to be 1. And so we've set it to be 255. And so that means it's going to be the maximum value in red that we can have. Now we also have values for our green component and our blue component as well. So row 1, column 1, again, all of these row column values should be the same to denote the same pixel. And the value in dimension 3 is 2, letting us know that this is the green value. And we've set the green value to be just 0, so essentially no green. And let's see if we set the value for blue. So that's going to be row 1, column 1. And then the third the dimension 3 is value 3, so that means it's our blue value, and we've set it to 0, which means that there is no blue present in this pixel. And so we can display it appropriately. So we've saved this as IMG, and what we want to do now is display it using the figure and image commands. We'll just be using the figure command here so that we can display the image appropriately. Don't want to use this in the code in your code. And so in order to display that image, we have here our pixel, which is completely red as we denoted from our declaration from above. So that has provided us with a display for plotting our image, and we can make appropriate adjustment to the axis to make those pixels square. We're also able to use the IMShow command to display images, and so you want to keep in mind that with the image command, what we're doing is we're going to display the data in our array as an image. And so we've passed in IMG and we've made sure to denote that it's an unsigned int. So this is the value that is going to be passed in to display the elements appropriately for the color pixel. And so it's going to display it essentially in this grid that we have here, an M by N grid with M rows and N columns for us to see. And so we could further specify how we want to display options to be, but for this example, we're just displaying the image that we created above. Now we can also use IMShow to display it appropriately as well. And so that is the command that we're going to use here to display. And so this will display the default range, and it tries to optimize it for a figure construct. And so executing this here, it looks like, so it's going to be right here. Might be a little problem with the way we have this displayed. So run. So if we want to display this image here, so we can use IMShow to display that image. Now let's see if we continue on with the 3x3 image display here. And so what we want to do here is we can establish a 3x3 image display that we just showed. And so in order to do that, we're going to have three pixels on row 1, 3 pixels on row 2, and then 3 pixels on row 3. And so for each one, we're defining the values, and this will show the image that we just were able to show. So we have the value for 255 for the upper left. We have our blue value for our middle value on row 1. And again, this is going to be for the pixel in row 1, column 1, row 1, column 2, which is going to be completely blue. And then we'll have our value for row 1, column 3, which is going to be 255. And so that's going to be completely, no, I'm sorry. So this is going to be completely green, and this is going to be completely blue. And then when we go to row 2, column 1, we have our values set all red, and we have blue or green set 2. So that's going to be our combination. And then for blue, we don't have any value for it. So no blue is present in that pixel. The middle pixel is going to be all red and all blue. And so forth. We do this for our 3x3 image. So if we run it here, up, sorry, got a mistake there. So we'll run our section here. And this is going to come up, and this is going to essentially display the value that we have for our 3x3 image. And we can display it a little better here to provide for a better representation. And so using this, we're able to represent it using vectors. So this will give us the same image that we were able to get here, but we're going to use appropriate vectors to display it here. So we've declared the image for row 1, column 1, and then we're doing it all for our red layer here. We have values of 255, 0, and 0. And then for row 2, column 1, we're going to do 255, 255, 0. And row 3, column 1, 255, 128, and 0. And so this is essentially putting it into a vectors where we've pulled our values for the top left, middle left, and the bottom left as well. And so we've represented it here. And so now what we can do is also do that for our green layer as well, and our blue layer too. And so when we execute, we'll get our appropriate image that comes up here. So this allows for us to enter the rows with each layer using vectors. And so we can also utilize an appropriate array for this construct as well. Now we can also use arrays again to create a 3x3 picture, and we're going to do this appropriately with layers as needed. And so in order for this to do this with the red layer, we're going to have our range values for 1 to 3. And for the column, we're going to enter the appropriate values for 1 to 3. And then for that red component, it's going to be outlined here where we've entered appropriate values of 255, 0, 0, 255, 255, and 0, and then 255, 128, and 0. And so this will represent that all of the red layer components for our 3x3 image. For the green layer components, we're going to provide the values of being 0 and 255 and 0. We'll have 255, 0, and 255, and 255, 128, and 0 to display. Then for our blue layer components, we're going to have values of 0, 0, and 255, 0, 255, 255. And then for our third value, we'll have 255, 128, and 0. And so when we do this, we're able to use our figure and image commands again to display, to determine, to outline how the colors come together for our 3x3 array here. So we're also able to do what we call target an image. And so there are different ways in which you are able to target an image. And so when we say that we're targeting an image, we're basically going to use a different way to display it appropriately. And so in this case, what we're going to do is we're going to set our values for our 4x12 image here. And so we're going to set it to be all zeros And basically what that means is in the absence of color, you have darkness. So for the values for our red values of rows 1 through 4 and columns 1 through 12, it's going to be completely zeros. And then for our green values for rows 1 through 4 and columns 1 through 12, it's going to be completely zero. And then for our blue values for rows 1 through 4 and columns 1 through 12, we're going to have our value be zero as well here. And so this is going to provide us essentially, we've denoted that it's no colors in red, green, or blue. And so that is going to provide us with a image that is a black image essentially. So we see our 4 by 12 grid here for our image that is displayed. So then what we also want to do is incorporate additional values that can be used to represent a 2 by 2 matrix that we can transpose as well. And so in this case, what we have is our values for red, green, our red values, and that is going to be 255 and 128, which is going to come up here as a slightly orange, and then 128 to 255. And then we have 128 and 0 to represent our blue values. And then we'll have 0 and 128. And then we'll have 0 and 255 for our green values. And then we'll have 255 and 0. And so we'll use a dart to display the image. And so displaying the image using figure image, and for our dart, we're going to have this grid that is represented here for display, where we have contrasts of orange and purple based off of the arrays that we've created. And so what we want to do now is transpose one within the other. And so here we'll use the command target, and our target is going to be from rows 3 to 4 and columns 4 to 5. We want it to be the dart image that we've created. And so we'll have our display the target, and then the image is now going to display for those columns within the original black area that we had. Here we've transposed our new image inside of the original. And so this allows for us to constrain one image on top of the other one. And so we can still continue to do that with other approaches as well. So in this example, we've created another target that is completely black, again, for both of the red, green, and blue components. And we want to work to display that. And then we're going to create a donor image here, where we've identified appropriate values that will be utilized for our red components. And then for our green components, it's just all zeros. And then for our black component, for our blue component, it is all zeros again. And so we'll have our display image, and we want to transfix that onto our black rectangle. And so that is able to show, and in this case, we see the components that are represented in red, as well as the components that are still black here. So the zeros in the red area are each represented here. And so that is where the image will cut off the appropriate red and keep it at black. So this is another way in which we're able to transplant one image on top of another. And so this provides us with an overview of working with images and using unsigned int values for some introductory work to manipulate pixels in Matlab.